So for this practice problem, we want to find the horizontal asymptote for q of x, and we have this kind of funky q of x here. So we're going to look at the limit as x approaches positive infinity of q of x and the limit as x approaches negative infinity of q of x. So let's start with positive infinity. So we're going to look at the limit as x approaches positive infinity of 1 over x to the fifth plus 3 plus sine of x over x. And using our limit laws, we can pass this limit through and find the limit as x goes to positive infinity of each separate term. So we know, based on previous problems, that this is going to go to 0. And since 3 is a constant, we know that this is going to go to 3. So the big question mark is what is the limit as x approaches infinity of sine of x over x? And we're going to use the squeeze theorem to figure this out. So we know that the sine of x oscillates between positive 1 and negative 1. And so if we build this function, we're going to divide each of these by x, and then we're going to take the limit as x approaches of infinity of each piece. And so we know that this equals 0, and we know that this equals 0. For the same reason we said above, that as the limit as x approaches infinity of 1 over x to any positive power is going to equal 0, which means that the limit as x approaches infinity of sine of x over x has to equal 0. So this has to equal 0. So then we know that this equals 0. And so 0 plus 3 plus 0, we then have this limit equaling to 3, sorry. If we do this same thing for the limit as x approaches negative infinity of each of these terms, we're going to get exactly the same thing. So we can, again, pass this limit through to each term. But the fact that it's negative infinity doesn't really change the answer here. This is still equal to 0. This is still equal to 3. And by the squeeze theorem, this also still equals 0, which means that this total limit here is going to equal, kind of ran out of space here, this is going to also equal 3. And therefore, we only have one horizontal asymptote, and that horizontal asymptote is at y equals 3.